Welcome to NASA's Summer of Innovation Lesson Support videos. I'm Kat Balch and this is Spaghetti Anyone from the Engineering Design Process module. Spaghetti Anyone is a great lesson to explore structural engineering. This video will give you a quick overview of how you can connect and extend the lesson to NASA. This is a picture of NASA's spin-off ISO Truss technology. This three-dimensional spiderweb-like structure is used in communication towers, freeway sign supports, farming and irrigation equipment, and even a mountain bike. Because of the unique design, it not only provides incredible support, but reduces overall weight. You can add depth to this lesson plan if you incorporate the engineering design process. If you've never taught with the engineering design process, you can find a separate video on the Summer of Innovation Spaghetti Anyone page. When you read the lesson plan for Spaghetti Anyone, you will see that the initial challenge is to create the tallest freestanding structure with the supplies that are given. In the original instructions it says to use tape for the joints, but what is great about this activity is there are a lot of ways you can enhance the challenge. Instead of tape, students could use marshmallows or gumdrops. You can also extend the lesson by changing the challenge and asking students to design a structure that supports something on top, like a marshmallow or building block. You can create other variations by encouraging students to keep budgets of supplies, time restraints, design restraints, or even using a past NASA design as a reference. The beauty of this activity is that you make it a simple icebreaker or a complete engineering unit. One of the ways you can begin the activity is by showing students the structural work done at NASA, or you could save the photos and use them after to compare. The International Space Station is constructed out of a series of modules connected together with nodes and trusses. These super strong trusses are built to hold the expansive solar arrays. The trusses were installed on a series of spacewalks taking over 10 years. But the International Space Station was not the first to use this type of structure in space. In 1985, astronauts built a 45-foot truss on STS-161B to test the best way to build a strong structure. Access was a high-rise tower composed of many small struts and nodes. EASE was a geometric structure shaped like an inverted tetrahedron. If you caught the word tetrahedron on the previous page, you can use that as a segue to get your students talking about geometry. A great activity is to send your students on a scavenger hunt for geometric patterns, either on the NASA website or around their own neighborhood. Students can explore different designs and see if any of the patterns they see would be a good place to start in their design or as part of their redesign of their own tower. Be sure that the students come away with the knowledge that all the successful designs include a repetition of shapes and patterns. These are the mighty Saturn V rocket test stands. They were built to test the structural integrity of the Saturn V rocket before we sent man to the moon. Now, the test stands had to be able to withstand various loads and even climate and natural disasters. A static load is the effect of gravity on an object or structure, and the dynamic load is the force that moves or changes when acted on the structure. Now, a good way to remember this is that a static is stationary and dynamic is moving. Engineers will be needed to be sure their test stand was strong enough to withstand the static load of the massive rocket and the dynamic load of the rocket engine as it fires. A key element of the engineering design process is to incorporate a formal debrief. NASA scientists and engineers participate in regular debriefs to keep learning and gaining new insight into projects they are working on. Debriefs take place as entire groups talk and share about their project. Like engineers, you will want your students to review and discuss both what went well and what didn't go so well. They will keep up with their design and how they all work together as a group. This will give you also a chance to review key concepts and compare what they learned in the challenge and each part of the design process. If your students had fun building spaghetti structures, you can extend the learning by connecting it to another NASA activity. One of my favorites relates to structural engineering is the Spacecraft Structure Engineering Design Challenge. You can find it on the Summer of Innovation website. In this challenge, students will undertake the problem of designing a strong but lightweight thrust structure that can withstand the launch of a bottle rocket. I know your students will enjoy this activity. Thank you for joining us as we explore together in NASA's Summer of Innovation.